Hello students, welcome to chapter 11, 3 dimension geometry. Students, in continue exercise 11th, question number 13. Find the equation of plane passing through the point -1, 3 and 2 and perpendicular to the given two planes. Students, I want to one of the perpendicular. It means normal of plane 1 and normal of plane 2 we will first take in the cross direction, then you get to normal of the third plane. So for the plane 1, very easy, you will cover to normal of the plane 1 and plane 2. X plus 2y plus 3z minus 5, and second 3x plus 3y plus z, and here I will take normal and 1, same normal and 2, and both normal you will cover to first 1 2 3. Here 3 3 1. I want to both perpendicular to on it. It means consider you will here one of the normal directions and second here, and third is a perpendicular to that. Consider in this way. That's your first normal, that is the second, and both perpendicular direction is that. It means I will show here n3 directions is a n1 cross n2. That's your normal. And here students, your first plane, consider in this way. That's your plane 1, that is your plane 2, and that's your plane 3. And this normal I will create to normal of n1 and normal of n2, and they cover to normal of n3. So normal of required plane, which is perpendicular to, which is perpendicular to both given plane 1 and 2. Yes, both given plane 1 and 2. So very easy. n3 is nothing, n1 cross n2, and both you know respectively. Putting down n1 I have students 1 2 3, and n2 is a 3 3 1, and apply in the simple way ijk forming. So n3 normal I j k, and my first value is a 1 2 3, and third 3 3 1. So it is a I minus j and the k. And now simple students, you will derive normal of third plane, I mean required plane. So here 2 minus 9, 1 minus 9, and last 3 minus 6. So students, your answer is minus 7i plus 8j minus 3k, indirectly minus 7, 8 and minus 3. So students, your third plane, it means this one, having the normal of third plane n3, we known minus 7, 8 minus 3, and students, read properly, you known the passing through point -1 3, 2. So this normal is a perpendicular to that plane. This is a plane, that is a normal perpendicular on it. So required plane is very easy. R dot n is equal to A dot n. N is just only, I will write down n3, R xyz, n3 minus 7, 8 minus 3. A means passing through the plane, that one, minus 1, 3, 2, that already given in the question, and n3 I will write down minus 7, 8 minus 3. So minus 7x plus 8y minus 3z, and is equal to 7 1 is 7, 8 3 is 24, and 3 2 is 6. So minus 7x plus 8y minus 3z, that is a 1 and 24, 25. So 7x minus 8y plus 3z minus 25 is equal to 0, and that's the students easily you know the answer for question number 13. And here students, easily we done that 13 is here over. Students, here one mistakes here, minus minus, if you common taking, then here minus 25, you will write down here plus 25. Now next question number 14. 14 also very easy. 2 points are given equidistance from the given plane, then find out value for missing P. Yes, question number, after that 13 we going to 14. If 2 points, one of the A 1 1 P and another point minus 3 0 1 are equal distance from the plane. Our plane is given R dot 3i plus 4j minus 12k plus 13 is equal to 0. Again repeat, 3i plus 4j minus 12k plus 13 and 1 1p and minus 3 is 0 and 1. So very easy students, just consider that's your plane. And here plane is derived 3x 4y minus 12z plus 13 is equal to 0. Here your two equal distance point on the given plane AM and students BN. A I have 1 1p, but B I have minus 3 0 and 1. Both are equal distance, means distance formula apply to one point to given plane. So very easy. Here A to M is equal to B to N. A to M, B to N. Apply the formula 3x1 4y1 12z1 plus 13 by under root. Similarly students, here 3x2 4y2 12z2 plus 13 by under root, and in under root L square plus M square plus N square. So we will write 3 square 4 square minus 12 square. Similarly here, but students, this value is indirectly cancelled, they are same, and x1 y1 z1 is this, x2 y2 z2 is this, and put down their values. So 3x1 is a 1, y1 is 1 and z1 is students p, and the value plus 13 say is equal to x2 y2 z2 is this point minus 3, y2 is 0 and z2 is a 1 plus 13, and here you derive the solutions. 3 plus 4 minus 12p plus 13 is equal to minus 9, 0 minus 12 plus 13. Now simple way you will cover to value of p in the two different types of way, one positive and one negative. So students, my answer is here 4 and 3 7, 7 and 13 20 modulus minus 12p is equal to, this side also same, here minus 13 and 12 minus, it is 1 minus 9 minus 8 modulus same. So 20 minus 12p is equal to modulus the 8. There are the two answers, one of the 20 minus 12p 8, otherwise 20 minus 12p minus 8, and here you will create two distinct value of p. So 20 minus 8 12p, it is 12. Definitely p cover to 1, and this side 20 plus 8 is a 12p, 28 upon 12, 7 4s are and 4 3s are. So your answer is students very easy, it is only and only 7 by 3, and one of the answer students only for the 1. So now students, we going ahead continue in the 15th one is also same way. just only given to two plane, but intersection between and passing through the parallel to x-axis. This is the IMP questions for exam level. Now continue students, question number 15, which is a IMP for exam level. Find the equation of plane passing through common intersection of plane 1 and plane 2 and parallel to x-axis. First of all, I derive the common intersection planes. Maybe plane 1 here, plane 2, and that the students, a common plane between them is this. That is a plane 1, plane 2, and that's the students plane 3. Plane 1 is a x plus y plus z minus 1 is equal to 0, and same as plane 2, 2x plus 3y minus z plus 4 equal to 0. And what the meaning for parallel to x-axis? Yes, definitely coefficient of x is 0. Just I explain about that in 2D. That's your x-axis, y-axis. Maybe one line passing through the something points of y, but parallel to x-axis. Maybe here a point I given the 5. So sure y is equal to 5. 0x plus y is equal to 5. Check. Here x coefficient is what? 0. Then that is a parallel to x-axis the line. Same concept here plane. So I will go to plane 1. In the plane 1, same apply to here x plus y plus z minus 1 equal to 0. Check. Here coefficient of x is equal to how much? 1. But I want to checking 0. So it is not equal to that. It means coefficient of x is not 0. So therefore plane 1 is not a required plane. Same checking students, plane 2. And that is plane 2 is a 2x plus 3y minus z plus 4 is equal to 0. Here also same meaning. Coefficient of x become 2, but I will check to 0. Yes, so it is not 0. It means again write down plane 2 is not a required plane. It means plane 1 and plane 2 is not your answer. So now I go to both common intersection, our lambda theory process. So suppose our required plane first plus lambda second is equal to 0 when lambda belongs to R. Our first concept is that x plus y plus z minus 1, and second similarly 2x plus 3y minus z plus 4. And students, here also I will arrange by our Lx, My and Nz in the standard equation of the plane. So just expansion x plus y plus z minus 1 plus 2 lambda x 3 lambda y minus lambda z and plus 4 lambda. Students, you will check first this x value and x value are combined. One more time check, 2 lambda x 3 lambda y minus lambda z plus 4 lambda. So your one of the equation is x, another y, another z, and constant is equal to 0. X I have 1 plus 2 lambda, y 1 plus 3 lambda, and z students here 1 minus lambda, and constant minus 1 plus 4 lambda. That's the your third equation of plane. But this plane is parallel to x-axis given. It means coefficient of x 0. It means students this value for coefficient of x I 0 taking. So mention here, but required plane already given in question C, required plane is parallel to, yes, x-axis. Therefore I will show coefficient of x 0, and that is 1 plus 2 lambda 0. It means lambda become exactly minus half. Sometimes given our same as to parallel to y-axis, then you take y coefficient 0. Either parallel to z given, then this 0, z coefficient. It means 3 numerical in same pattern asking in exam. So now required plane, you will cover 2. That in this equation, students, x plus y plus z minus 1 plus lambda 2x plus 3y minus z plus 4 is equal to 0. You just putting value of lambda. So my answer is minus half 2x plus 3y minus z plus 4. These two are multiplied, this one are this side multiplied. So 2x plus 2y plus 2z minus 2 minus 2x minus 3y plus z minus 4. So does these are cancelled. Indirectly coefficient of x is 0. So 0x plus minus y, because 2y minus 3y and last 3z minus 4. It means minus y plus 3z minus 4. Just to recover your answer, y minus 3z plus 4 is equal to 0. Just I check my answers, it is correct. To y minus 3z plus 4 is equal to 0, and that's the students your simple way answer. I think here over one mistakes, minus 2 minus 4, it become minus 6. Here minus 6 students, and that is your plus 6 answer. Then x minus 3y plus 6z is equal to 0, and that the students correct answer. Now students, I going ahead to our question number 16. That is also different types of questions. Find the equation of plane which is perpendicular to P and passing through P to origin side's value. So students, in question number 16 now, if O is the origin and coordinates of the P given 1, 2, minus 3, and find the equation of plane passing through P but perpendicular to OP. Students, the perpendicular to OP means I just draw, this is my required plane maybe, and that's your perpendicular on it. I will take that P here passing through points, and O is here our origin. P I know that 1, 2, minus 3. Very easy. Normal of required plane which is parallel to our P to O directions. Yes. So I just write down required plane having normal is a N, definitely P to O towards going. So I will show that PO. It means O position minus P position. It is minus 1, minus 2 and 3. Now required equation of plane having normal ready. This normal is already cover you, minus 1, minus 2, 3, and very easy, passing through. Where it is passing through? Yes, passing through given the point P. Yes, read the question. Find the equation of plane passing through P. So I will write down 1, 2, minus 3. And formula known, R dot N, A dot M. A means students passing through point apply. Here you also write down P, and that is P is also students very easily true. Now what is R? X, Y, Z. N is normal, minus 1, minus 2, 3. Same P, 1, 2, minus 3, and normal, minus 1, minus 2, 3. Now go to simple dot product between them. So this answer is a minus x, minus 2y, plus 3z. And here students, 1 and minus 1, minus 1, 2 2s are 4, and 3 3s are 9. 9 and 10, 10 and 4, 14. Yes, it is minus 14. Minus common and cancel, overall is equal to 14. So x plus 2y minus 3z is equal to 14, and that the students easily our question number 16 is also done. Now I going one more biggest question, and that is IMP questions for exam oriented. Our question number 17, which is very most IMP questions. Now continue students, question number 17, which is again I telling very most IMP for exam oriented. Find the equation of plane which contain line of intersections between plane 1 and plane 2 and perpendicular to third plane. I just show first individually plane 1, plane 2 and plane 3. Plane 1 I have x plus 2y plus 3z minus 4. Very easy. Same I going to plane 2. Plane 2 is a 2x plus y minus z plus 5. And similarly students, plane 3 you will cover to 5x plus 3y minus 6z. 5x plus 3y minus 6z plus 8 is equal to 0. I just derived all first of all normal. Yes, here normal N1 directions is very easy. 1, 2, 3. Similarly students, normal to N2 they have to 2, 1, minus 1, and last normal N3, and that normal is also students covered to 5, 3, minus 6. But my target is what? Yes, our target is a plane 1 and plane 2 between common intersections. Means this is your plane 1. Consider that simple drawing. I will show that it is plane 2, and that the students I will cover my answers. That's the plane number 4. So here plane 1, here plane 2, and here write down plane 4, the third plane. After that I will derive in the next half section of this numerical. First plane is a x plus 2y plus 3z minus 4 is equal to 0. Second same you will derive to 2x plus y minus z plus 5 is equal to 0. And now I cover to both common intersection. But before I check, plane 3 is a perpendicular to plane 1 and plane 2. Yes, so I checked first n1 dot n3. n1 dot n3. What's the n1? n1 is a 1, 2, 3. n3 is a 5, 3 minus 6. So my answer is a 5 ones are 5, 6, and 6 3s are 18. 6 and 5, 11 minus 18, minus 7. But not 0. It is plane 1 is not our required plane. Similarly, n2 and n3 also check. n3 dot n2. So my n2 is the students 2, 1, minus 1. And n3 is a 5, 3 minus 6. My answer is a 5 to the 10. 3. Same as 3. 1s are 3. And here 6 1s are 6. It is a 6 and 3, 19. But definitely never 0. It means my plane 1 and plane 2 is not our required plane. That's our first conclusion. So easily I will show that. So required, so given plane 1 and plane 2 is not our required plane. Now I will start to plane 4 derive. So suppose required plane, third plane already I show in the next part. So here students, it is a plane 4th is a first plus lambda belongs to R. It means I draw another figure with plane 3 and plane 4. These are lambda related. First 1x plus 2y plus 3z and minus 4 is equal to 0. And second plane 2x plus y minus z. Yes, 2x plus y minus z plus 5. This is your students plane number 4. But lambda value is only missing. Very easy. Just like converting into expansion. 2 lambda x, lambda y, lambda z, plus 5 lambda is equal to 0. So students, here you will cover 1x, another y, another z, and here constant is equal to 0, and that means students we covered to our normal form Lx, My and Nz equations. So students, in the way of your Lx, My and Nz, 1x and 2 lambda x, so 1 plus 2 lambda, that are covered. Similarly 2 plus y, also 2 and lambda, and cover to z 3 minus lambda, and constant students minus 4 plus 5 lambda, that you create final equation of our plane 4. Now students, this is a plane 4. I will draw here, which is perpendicular to plane 3. So here your plane, that's your perpendicular to, this is the plane 4 means normal of plane 4, and that is plane 3, normal of the plane 3, and plane 3 normal already known students here, 5, 3, minus 6, and here your plane 3, that is your plane 4, and this normal is covered to 1 plus 2 lambda, next 2 plus lambda, and next 3 minus lambda, and these are our 3 simple way your normal to N4 and N3. Now apply both of the perpendiculars, so dot product 0. So now plane 3 perpendicular to plane 4, it means N3 dot N4 is equal to 0, and both apply dot product. You simple create value of the lambda here easily students. So you just apply on the value wise N3 dot N4. My N3 is this value 5, 3, minus 6, and here 1 plus 2 lambda. Similarly 2 plus lambda, same as 3 minus lambda, and dot product 5 1s are 5, 5 2s are 10, 3 2s are 6, 3 lambda, and last 6 3s are 18 plus 6 lambda. Now cover to easily value derive for lambda. So 10 and 6, 16 and 3, here 16 and 3, 19 lambda, and here 6 and 5, 11, minus 18, minus 7, lambda become 17 by 19, 7 by 19. One more time check, 10, 6 and 3, 19, and here 6 and 5, 11, 11 minus 18, which is minus 7. So required equation of plane, you will again putting down in these equations value of lambda here, that's your standard suggestions, x plus 2y plus 3z minus 4, and similarly here students 2x plus y minus z plus 5, and lambda you known 7 by 19, just putting 7 multiply inside, 19 multiplying that side. So 19 1s are 2s are 38, 3s are 57z, and 19 4s are, yes, 9 4s are, yes, 76, 9 4s are 36, 3 carry, 4 1s are 4 plus 3 7, this side 7 2s are 14x, 7 by 7z, and 7 5s are 35. Now cover to like term additions 19 and 16, yes, 9 and 5 13, 1, 33x, 38y, 7y, 45y, 57z minus 7z, 50z, and minus 76 plus 35, it's covered to minus 76 plus 35, it is a 1, and a 41. Minus 41 equal to 0, and here students you are easily answer for this equation of the plane 33x plus 45y plus 50z minus 41 is equal to 0. Students, here over. Now here students I will stop this video, and further explanations for related this exercise I will explain same as to in the next part. Bye bye.